Your homework for tonight asked you to graph each of the following equations and label them. And so you'll notice in the key that I did it in color so that I could distinguish each of the graphs. If you have color, you're welcome to do that. If not, it will likely look a bit more like what I'm going to do here on the video. So our first graph is y equals 3x minus 4. We want our m value, which is in front of the x, that's 3. We want our b value, which is negative 4. And when we're going to graph, we're going to, again, begin with the b value. So the b value is negative 4. 1, 2, 3, 4. That's going to be right here. Now we know that our slope is a positive 3, which means I go up 3 and over 1. And since slope is a constant rate of change, I can go up 3 more and over 1. And so we'll start to see that there is a line that emerges out of that, which looks something like this. Well, now we move on to the next equation. Y equals x plus 1. X has a positive 1 in front of it. My b value is also going to be 1. Since we start with the b, for our beginning has a b value of 1, so on our y-axis we come up to 1. We have a slope of positive 1, which means we rise 1, we go over 1. We rise 1, we go over 1. Since I'm starting to get a curvy on my line, I'm just going to go ahead and stop right there because you get the gist. Now, obviously, we're going to end up with a number of equations all layered on top of each other, and you were asked to label them. So this one down here was y equals 3x minus 4. This other one was y equals x plus 1, and you would get the other two onto one graph and provide its labels. Number 2, graph using the x and y intercepts. Now we've done quite a bit with x and y intercepts so far. And for the most part, we've identified intercepts on graphs. We talked a little bit today in our review on how we could start to think of using intercepts for being able to take our information to the graph. And so I'm going to cover that real quick in the video here. Now we know that our x-intercept is where our line will cross the x-axis. And the only place it's going to cross the x-axis is where it has a y value that is 0. Now the opposite is true for our y-intercept. When x is 0, in other words, it doesn't shift anywhere to the right or the left, it just stays right there, then we find out where our intercept is, up or down. So all we have to do at this point is plug in our ordered pairs. So if y is 0, I plug y in, and we can see that if I plug a 0 in for y, I'm going to get 0 times 3, which is also 0. And that leaves me with 2x equals 6. Now since 2x equals 6, we divide both sides by 2, and x equals 3. Next we do the same thing for our y-intercept. The x value has got to be 0 for a y-intercept, so I plug a 0 in for x. 2 times 0 is still 0. So that will leave us with 3y equals 6, and we divide both sides by 3, so that y equals 2. Now we've talked a good bit about how you only need two ordered pairs to be able to graph a straight line. We now have two ordered pairs. Our x-intercept, 1, 2, 3, 0. And our y-intercept, 0, 1, 2. Which means with just this information, we could write an equation. Y equals, starting from 1 point, I'm going down 1, 2, over 1, 2, 3. So negative 2/3 x, and my y-intercept is at positive 2. We didn't need the equation, but we could certainly write it just using what we know of equations so far. And so now we can connect the dots. And we end up with a line that looks something like that. Graph using a table. Again, we did a lot of graphing using tables in our functions unit. If I plug in a negative 2 for x, negative 2 times 2 is negative 4, minus 1 is negative 5. Negative 1 times 2 is negative 2, minus 1 is negative 3. If I plug in a 0 for x, 0 times 2 is 0, minus 1 is negative 1. We can already see that we're developing a constant rate of change as we decrease, as that corresponds with our constant rate of change as we in our x values. 1 times 2 is 2, minus 1. Two times 2 is 4, minus 1 is 3. Now we can graph any of these or all of these on our graph, and that will give us an equation of a line that, or a line that represents this equation in this table. The backside is predominantly a review of all of the content that we've covered this week. Find the slope of the given 2 points, so we're going to use our slope formula. y2 minus y1 over x2 minus x1, where my y2 value would be 5 minus 3 over 2 minus 8. 5 minus 3 we know to be 2. 2 minus 8, negative 6. So we can simplify. I'm going to bring the negative sign to the numerator. 1/3. Number 5, I'll go ahead and do B for us. No, I'm not going to do B. I'm going to do C, because C was the one that has the multi-steps. So 0 minus 5 over negative 2 minus 0. 0 minus 5 is negative 5. Negative 2 minus 0 is negative 2. So we end up with 5 halves being our slope. Well, now that we know our slope, we can plug that into y equals mx plus b so that we can find the equation of a line. Now, when we're using y equals mx plus b, we're trying to first find out what our b is. We already know what our m is. We also have options up here for our x and y. The only thing that needs to happen is whatever x we use, we need to use its y. So I'll go ahead and use my first ordered pair here. It's got a y value of 5 equals my m value is 5 halves times my x value of 0 plus b. Well, I like using an x value of 0 because 0 times 5 halves is going to cancel that out. And so we can see that B is equal to 5. And now that I know my B value, and I know that my M value, we can rewrite our equation. Y equals my M value of 5/2 X plus my B value of 5. Now, that should be enough review to cover everything that we did in our review today in class, and that which we've covered this past week and the week prior to February break. Have a good evening.